Hello everyone, this is Hamza Noor and today we have the questions of the same paper of mechanics M1 A-Levels Maths 9709 May June 2013 variant 3, and where we have question number 4. The link to the question number 1 to 3 lecture is in the description. You can see from there. So let's start. Question says that an aeroplane moves along a straight horizontal runway before taking off. Alright, it starts from rest at O and has a speed 90 meters per second at the instant it takes off. While the aeroplane is on the runway at time t seconds after leaving O, its acceleration is 1.5 plus 0.012 t meters per second squared. Find the value of t at the instant the aeroplane takes off. Alright, so first thing is you've been given the acceleration, which is 1.5 plus 0.012 t meters per second square. So let's start with the working. Acceleration is equal to 1.5 plus 0.012 t meters per second square. Alright, first thing is that if you've been given the displacement and you differentiate displacement, you will get velocity. If you differentiate velocity, you will get acceleration. So this means that if you integrate acceleration, you will get velocity, and if you integrate velocity, you will get displacement. So here we have been given acceleration and we need to find the velocity. So v will be equal to integral of acceleration with respect to time. Alright, so this goes like this: 1.5 plus 0.012 t dt. So velocity will be equal to 1.5 t plus 0.012 t squared over 2 plus c. Alright, so this is v is equal to 1.5 t plus, how much is that? 0.012 divided by 2. This is 0.006, just to make sure, and plus c. Alright, so the question says that it starts from rest at O. Obviously at rest the time will be equal to 0. The time would be equal to 0, and this also means that the initial speed will also be equal to 0. So if you put 0 in this equation, so the constant term c will also be equal to 0. Alright, so the equation of the velocity is 1.5 t plus 0.006 t squared. Alright, what's next now? The information which we've been provided over here is that while the aeroplane is on the runway at time t seconds after leaving O, its acceleration is 1.5. Okay, 1.5 plus 0.012 t. Okay, it starts from the rest at O and has a speed 90 meters per second. So it has the speed 90 meters per second at the instant it takes off. So what you will do is simply put v is equal to 90 in this equation and find the corresponding values of t, because it is a quadratic function. So let's see which values of t would be acceptable and which value of t will be ignored. Alright, so here you can just simply solve the quadratic equation. 0.006 t squared plus 1.5 t minus 90 is equal to 0. So dividing all three terms by 0.006 in order to make it simple. So this goes like t squared plus 1.5 divided by 0.006. This will be 250 t minus 90 divided by 0.006. This is 15,000. Minus 15,000 will be equal to 0. Now all you need to do is solve this quadratic equation and you will get t minus 50 multiplied by t plus 300 equals to 0. Alright, always remember, if you are solving a quadratic equation in your Casio calculator or whatever scientific calculator you are using, so all you need to do is you need to mention these factors over here. Alright, so it's very important. So t will be equal to either 50 or t will be either equal to minus 300, and since you know that the time cannot be with minus, so it is ignored. So your only answer is t is equal to 50. T is equal to 50 seconds. So basically the aeroplane leaves the ground, it takes off when the time is equal to 50 seconds. So let's move to the next part. The next part says that the distance traveled by the aeroplane on the runway. Alright, we need to find out the distance traveled by the aeroplane on the runway. We have calculated the equation of velocity, so all we need to do is integrate velocity in order to get the equation of displacement. So as I've explained earlier, when you integrate velocity you will get displacement. So s is equal to integral of v with respect to time. S is equal to 1.5 t 1.5 t plus 0.006 t square and c was equal to 0, so no need to mention it, and here you just integrate it. This will be 1.5 t squared divided by 2 plus 0.006 t cube over 3 plus c. So this will be 1.5 divided by 2. How much is that? 0.75 t squared. S is equal to 0.75 t squared plus 0.006 divided by 3. This is 2 multiplied by 10 to the power minus 3. You can also write it like this: t cube over 500 plus c. Alright, so at the instant when t is equal to 0, the velocity was also equal to 0, so the displacement was also equal to 0 because aeroplane is starting from the rest, so c is also equal to 0. So s is equal to 0.75 t squared plus t cube over 500. So all you need to do is you need to find the distance traveled by the aeroplane on the runway. For how many seconds did the aeroplane was on the runway? As in part 1 we have calculated that for 50 seconds the aeroplane was on the runway before it took off. So all you need to do is put t is equal to 50 in the equation of displacement. So you will get 0.75 multiplied by 50 squared plus 50 cubed over 500, right? 0.75 multiplied by 50 squared plus 50 cubed divided by 500. So this is giving 2125 meters. Alright.